So this is how an electric car will look like in terms of a transparent image. So what you are able to see here is a front wheel drive electric four-wheeler where this is a electric traction motor. So we are going to focus on electric traction motor. Sometimes it is also known as a propulsion motor or it is called a traction motor. So the motor which is responsible for developing the power on wheels, that is called a traction motor or a propulsion motor. So this is what we are going to discuss about in this course, but at the same time we need to understand what are the other components, right? So there is a motor over here, and the yellow color represents the traction battery pack. So an electric vehicle requires multiple number of cells and modules to be connected in series parallel, and that is what you are able to see here. So there will be a charging port, and the motor cannot directly drive the wheels. There will be mechanical power transmission on the shaft of the motor, which will be basically a reduction gear. And here you have a different system for controlling the motor. So if you have just a battery and a motor, will you be able to run the electric car? The answer is yes, but you will be definitely not able to control the speed of the electric car, right? So in certain applications like an electric forklift and some other applications, there may not be any need of a power electronic converter, but in order to change the speed, in order to translate the voltage and current from one level to another level, we will definitely need power electronic converters. And there are a lot of other systems which are not included in the image, but there will be auxiliary battery in case of failure, or in case of auxiliary power to other systems, it can be used. There can be a thermal system for cooling of the motor and battery systems as well. So this is just an inside view of an electric vehicle. Now what we are going to learn in this course is about electric traction motor. So let me simplify this in terms of a block diagram. So here is a simple block diagram of an electric vehicle. So the arrow indicates the direction of signals or the power flow. So if I explain you the direction of power flow, the battery is going to provide power to the power electronic converter. Now power electronic converter will change this fixed battery voltage into the required voltage of the electric motor, considering the user inputs. So what are the user inputs? User inputs are basically the accelerator and brake paddles. So from accelerator and brake paddles, this power converter will decide how much is the voltage to be applied to the electric motor. What electric motor is going to do with the voltage and current? It will be translating the voltage and current into speed and torque. And now this speed and torque are going to be applied to the vehicle body, which is going to run under the formatted environment, under environmental conditions which are present. So this is a simple block diagram, and here is the red color block highlighted, which is of our interest. So what electric motor is going to provide on the speed and torque, we can actually work in the reverse direction, and we can try to understand what is going to be the motor power rating in case we are considering the specifications for vehicle body and the given environmental conditions. So there are two kind of approaches where you put an electric motor inside a vehicle and try to identify how much is the top speed and how you are able to control the vehicle, right? The other strategy is you actually back calculate how much is the motor power required from the available conditions, right? So basically you observe the motor from the shaft perspective. This is where going to be our eye for the next part of the course, right? So we are going to look at in this direction from the electric motor. So this is a simple block diagram representation, and let's now try to understand about the electric motor as well. So how does an electric motor look like, or what are the features, right, or which motor is used for an electric vehicle? So let's answer this question. So if I ask you the same question, which motor is right choice for a given EV application? So let's try to figure out an answer for this question. So actually there are no standards yet established for the choice of an EV motor, because there are lot of technology involved in the design of an EV motor. At the same time, this technology is not matured yet, or people are trying with different types of motor. So how do we decide about a type of a motor, and how do we learn from all those types of different motors? How do we come to a conclusion that this is going to be the right fit? So the answer is actually not available, right? So there is no right motor for an EV application. Why we don't have any standard motor for an EV application? So for example, if you take the application of a pump, so if you have a water pump which is going to change the level of the water from underground tank to overhead tank, people will usually prefer single phase or three phase induction motor. Now that is a quite mature application, and the motor is also quite rugged, right? Or it's quite known that we have usually single phase or three phase supply available as outlet, as a power outlet, and we know that this motor will be easily able to perform the task. Now what is the case in electric vehicle application? So let's try to figure out the answer for this question. So actually the customized motor design is preferred. So there is no standard motor which you can take and place inside the electric vehicle. In order to satisfy the EV requirements, the customized motor design is preferred. So there are actually many choices within the same category of a vehicle, right? So let me try to explain more about this question. So how many types of electric vehicles are possible, right? So you may think in terms of an electric bicycle to electric scooter, maybe it's a four-wheeler or a minibus, or it may be more electric aircraft, or a truck and motorcycle as well, right? And maybe drone, or maybe some other spatial vehicle applications. So there are wide category of vehicles, right? And what we call as electric vehicle, it's not only electric car, it can be electric scooter, or it can be more electric aircraft as well. So which EV motor is preferable in which application, that is not fixed, right? So there are no standards yet available for the choice of EV motor for all these applications. Now if I reframe the question, if you ask this kind of a question, the answer can be a counter question, and this counter question can be like this: what type of footwear people are going to prefer, right? What kind of footwear human beings will prefer? So do you have any particular answer? Probably no, right? Because there are wide category of footwears available, right? That depends on weather condition, that depends on one's gender, it depends on one's style and comfort, right? So there are no actual answer to the question that which footwear are preferred by humans, right? So this question is also similar. So which motor is preferred for an EV application? It's an unanswered question. So if I talk about different types of footwear, there are equally amount of different types of motors also available. So as you see in the image, there are varieties of motors which are mainly classified as AC motors and DC motor according to the type of supply, but there will be mostly the motors of different categories, right? And each and every motor is going to be meant for a given application. For example, the motor used for drone cannot be used for a bicycle. The motors used for a tractor application may not be suitable for an electric motorcycle. So there are specific motors for specific needs. So once you know this, let's move ahead and let's have a look inside the electric motor. So how does an EV motor look like? So an EV motor is going to be something similar to this. So this is an image of Chevrolet Bolt electric vehicle, and here is the motor which is integrated along with the transmission system. So what you see is the top half of the system. You can see the windings which are coming to the three ends in the terminal box like this over here, and it's basically going to have a permanent magnet rotor inside, where this is the final shaft coming in which will go to the axle, and this will provide power to the wheels. So this is one of the image of an electric vehicle motor. So how does an EV motor look in the situation of a disassembly, right? So if all the parts are going to be dismantled, and if we just focus on what is the motor construction, it will look something like this. So here is the actual internal construction of a popular electric vehicle motor, which is permanent magnet synchronous motor. So what you have is a stator over here, and this stator is basically the steady part of the motor, and the stator is divided into two parts: stator core and the stator windings. So the stator windings are inserted into the laminated stator core with this slot and tooth arrangement. Now at the end of this, there is a rotor inserted, where you have a rotor core which is like this, and the rotor is not having any windings, but the rotor is having permanent magnets. So the permanent magnet bars are inserted into the rotor, and this is how an EV motor will look like. Now if you take a cross section across this, you will be able to understand there is a big circle known as a motor, and there is a small circle known as a rotor which is surrounding the stator. So this is a very fundamental construction of an EV motor. If you are not able to understand at this moment, we are going to dive deep into this once we know about the motor power estimation. This is just to ensure that you have enough idea about a dismantle condition of a motor. So let's not look into this more now and try to understand about the different types of EV motors, right? So if you have understood about various types of motor, so in basic electrical engineering you might have learned about various types of motor. These motors are AC motors and DC motors, and it can be again classified into several things, right? So if we consider for EV application, the two major considerations are the permanent magnet DC motors and AC induction motor. So let's try to have a look and let's try to understand how these two motors are actually going to compete with each other, and which one is more popular, and what automakers are preferring to have as the motor technology. Now, when I say about motor technology, this is not just one choice. This is just one application, and a four-wheeler motor such as Chevrolet Bolt can be of this type. Now, there can be other technology as well, which is called in-wheel technology. So if you see at this image, this motor is completely different than the previous one. So in the previous motor, we had a stator surrounding the rotor, but here we have the outer rotor which is connected directly with the wheel and tire. So this is called out rotor motor, or it is also known as in-wheel motor. So in-wheel motor is where the stator remains fixed and it is attached to the axis or the central axis of the assembly, and the rotor is permanent magnet, and you can see the permanent magnets inside the periphery of this part, and stator is having windings over here. So this is one such application of a motor where it's entirely different motor. So EV motors can be of different type, and this particular assembly is in-wheel motor for specifically developed for four-wheel application by Protein Electric company. So there are varieties of different motors, and there are varieties of manufacturers of EV motors as well. So let's move ahead and understand the types of motors for EV. So as I said, there are mainly two types of category of EV motor. One is AC induction and another is a permanent magnet motor. So if we see this two categories and if we try to see which one is more popular, or without going into the technology, if we talk about which motor is available commercially or which motor is deployed in the vehicles, right? So let's take a survey results done by Adams Intelligence and try to understand which are the motors used in typical electric vehicle. So what you are seeing on the y-axis is number of electric vehicles sold. So for this much number of electric vehicles, how much is the percentage where it is shared by different types of motor? And what are the different types of motor considered over here? One is permanent magnet motor. So mostly the permanent magnet motors are here classified into permanent magnet synchronous motor, and there is another category called induction motor. The third category here is electrically excited synchronous motor, where we do not have any permanent magnets. And one of the category can be switch reluctance motor as well in this category. So electrically excited synchronous motor, induction motor, permanent magnet, synchronous motor. These are the three main categories of electric vehicle, and what you are able to see over the period of years, the number of electric cars on the road are increasing. Now, which are the types of motor used in that electric vehicles? So mostly those vehicles are using permanent magnet synchronous motor, as you can see as a dark blue color over here. But induction motors are equally getting popular. So let's try to compare these two different types of motor, which is induction motor and permanent magnet motor. So if we have a look at another survey result where it is compared in terms of three parameters: weight, cost and efficiency. So let's have a look at this survey results. It's again done by Adams Intelligence Research, and if you can see in the first report, EV motor weight is compared. So weight in kilograms and their proportion of material what is used, that is covered over here. So permanent magnet motors will be lightweight compared to induction motor. That is what we can conclude over here. So how much amount of steel and copper as a material they are going to use, that is also compared over here in terms of weight. So motor weight is very important parameter in terms of electric vehicle application, because it has to consider its own weight and considering the space or volume available for motor to fit in the automotive application. So one comparison is from the point of weight. Induction motor is going to be not the preference if you are considering the weight criteria. The next is bill of material. What is a bill of material? It is basically the cost of all materials involved in the motor. So this is a typical cost per kilowatt for a motor which is permanent magnet motor. It's around $175, and for an AC induction motor it is slightly less than that. And here is a comparison of different types of material. So REE magnet stands for rare earth magnets. So this rare earth elements basically will be the major factor in the cost of an electric vehicle or the motor used for an electric vehicle. So here is the important comparison. So when you are going to consider a cost of an electric motor, definitely the permanent magnet motors will be more costly. Now, at the same time, if we consider the last part of comparison, which is the efficiency. So efficiency of a permanent magnet motor is way better than an induction motor of highest efficiency. So here the induction motor with a NEMA premium or high efficient induction motor is considered for the comparison. So if it is compared with a permanent magnet motor, usually the permanent magnet motor efficiencies are higher, and here this efficiency is plotted in terms of variation in the speed on the x-axis. So if you consider the factor where your vehicle is running at a lower speed, at a lower RPM, the difference in the efficiency is huge, right? So if you consider this difference of efficiency between the permanent magnet motor and the induction motor, you will definitely be able to compromise on the cost involved for permanent magnet motors. So in a way, permanent magnet motors are better for electric vehicle application, but at the same time, people are also evaluating different types of motor without permanent magnet, and it is basically induction motor and a switch reluctance motor. So induction motor is also popular. Tesla Model S and probably Mahindra E2O. These are some of the examples of car which are using induction motors. So what are the advantages of using induction motor? Basically, whenever the cost is compared for this research report, it is considering the rare earth magnet availability and its mining related cost involved. Now, as the EV demand keep on increasing, the material available for this magnet may also fall short and the price of the permanent magnet may increase. So keeping that into mind, people are also trying to look at the option for new type of induction motor where the efficiency are improved. So this is something about the comparison of PM and non-PM types of EV motors. So this is the end of first video. We will again meet in the next video. Thank you.